sector areas are going to be what we're going to look at today. And we are going to start with the area of a circle and a circumference of the circle, because that's where both of these come from. Area and circumference are not the curriculum that we're looking at, but it's necessary for being able to find area of a sector and length of an arc. So, just some basic review. Area of a circle is pi r squared, right? If you don't have that already on your note card, we might have put it on it earlier, but I would have that there. It's probably on some of the earlier note cards with the volume stuff, but if you want to put it here too as well, that's fine. Oh, I don't want that. Okay. So if we want to find the area of this circle below, all we have to do is do pi times our radius, which is 9 squared, and we will type it into the calculator. So I'm going to get this calculator out today. I haven't had it out in a while. So let's make this way. There we go. And okay. So pi times 9 squared is going to give us 254.469. So 254.469 centimeters squared. You may also see this as 81 pi centimeters squared. Sometimes they don't multiply the pi in there. Okay? So straight area of the circle is what we're doing there. The circumference of a circle, there are two different formulas you can use for this. My favorite one is just pi times diameter. The reason I like pi times diameter better than 2 pi r is because 2 pi r and pi r squared just sound too much alike and are easy to get mixed up. So I always think of it as pi times the diameter. However, you can also use 2 pi r because 2 times r is the diameter, right? 2 times the radius is the diameter. So these are equivalent to each other. So you can use whichever one you would like for this. For example 2, it says find the circumference of a circle with a diameter of 6 inches. They gave the diameter here. So I would just do 6 times pi for that circumference. And if you do that in the calculator, 6 times pi, we are going to get 850 if we round up. And this would just be centimeters. Oh, look at my terrible notes right here. This says the area of a circle, and it should not. Hold on. Let me go fix it. Get out of that. That right there should say circumference of a circle. So fix that on your notes for me. There. Instead of area of the circle there twice, that should say circumference of a circle. Okay. Area, we're talking about all the area inside of the circle. With a circumference, what are we talking about? What does the circumference give us? It's like perimeter of a circle. It's the distance around the outside, right? So that's why this is in centimeters and this is in centimeters squared. So arc lengths and sectors relate to this directly. So let's talk about a sector first. Here. A sector is a section of a circle defined by a central angle and its corresponding arc. So for example here, on this picture that I'm looking at, I have this central angle and the arc that goes with it. Those are the boundaries of this area. So we're finding the area basically of a slice of the circle, right? You can think of it as like a slice of pizza, right? We're finding the area of that slice. So the formula for this is going to be theta divided by 360 times pi r squared. Basically, you're just finding a fraction of the area, right? We don't want the area of the whole circle. We only want area of this piece of the circle. And in a circle, we have 360 degrees total, but we only want 150 of it for this particular problem. So if I'm finding the area of a sector for this, I would say that the area equals 150, because that's my angle right here, over 360. So that theta right there is your angle. Times pi times the radius squared. It's basically just telling you what fraction of the circle you have here. You have 150 out of 360 possible degrees there. So we can just type that into the calculator and make sure you use some parentheses here or it will not give you the right answer. So 150 over 360 times pi times 2 squared. And we'll get 5.236. And this is an area, so it is going to be in yards cubed. Not cubed. Cubed would be volume. We want squared right there. 5.236 yards squared. Everybody okay here? All right, so I have an important question for us to consider. This is a real-life dilemma that you might run into one day. So you're going to share pizza with a group of friends. If the group orders a number of medium pizzas, then you will get 4 slices. If the group orders a number of large pizzas, you will get 3 slices. Which is the better deal for you? What do you need to know to solve this problem? So, you know, a lot of times pizza places will have deals where, like, you can get 3 mediums for this price, or you can get 2 larges for this price. So whatever deal is going on here, they have figured out that you can get this many medium pizzas or this many large pizzas. And what it turns out is that, you know, you probably have like the same amount of money and you can either buy this many medium pizzas or you can buy this many large pizzas. And just buy, you know, 8 slices probably per pie there. You have, if you get medium pizzas, you will get 4 slices. But if you get large pizzas, you'll only get 3 slices. So you will get fewer slices if you order the large pizza. The question is it less pizza? Because what's going to be true about your large pieces? They're bigger, right? Large pieces are going to be bigger than smaller pieces, than the medium pieces. So we need some information to solve this problem. Okay, what information do we need to know? What do you think? Size of the pizzas, right? So we need to know size of pizzas. And whenever you say size, you don't mean medium and large. What do you mean? Right, we need in inches, so like a diameter or a radius will do of these pizzas. What else do we need to know? What we are finding is how big each slice is, but we're not going to be able to like look that up. Probably, hopefully, so that I don't have to make this up. I think we're going to be able to look this up, although I will admit these are Miss Martin's notes, and I didn't go look up on Pizza Hut's website. If I can look this up, we're going to check it here in a second. We might have to go with my made-up numbers. What else do we need to know? You would want to know the price of the pizzas if this was like real life. For this problem, somebody's already figured out the prices and decided that if you get medium pizzas, you get 4 slices, and if you get large pieces, you get 3 slices, and I think that would be for the same amount of money. So in real life, we would definitely need to know that. For this problem, we don't have to consider that. Yes? Yes, we need to know how many slices per pizza. Right, because you could cut a pizza into 25 slices if you wanted to. If you do that, the pieces are going to be little bitty tiny, right? Or you could cut a pizza into 4 slices, and they'll be great big. Probably. We'll see if we can look it up, but I'm pretty sure that we're not going to be able to look that up, but I think 8 is pretty standard. So we'll probably go with 8 for that. Anything else we need to know? I think we can do it with these 2 pieces of information. So, all right, at the danger of Googling something with the screen on, I'm going to try it. All right. Let's see if let's just go to Pizza Hut's website. Pizza Hut. Let's see if it says it just on their menu.
$3 more for stuffed crust.
We'll talk about some stuffed crust here in a minute on some of our others. Let's see.
You ever had their wings?
I haven't.
Surprisingly really good.
Really, I have not. We don't do Pizza Hut a lot. We might should. All right. Let's see. Let's just see if it tells us. I don't really want.
Could get us a
We
pizza.
could, yeah.
We could get a pizza.
Yeah,
And we could really
yeah.
measure it. There's so little of that.
Yeah.
I think that
To test out our theory here, get some mediums and larges and see. Takes,
we got 9
yeah.
people, so
Yeah, okay.
we all shipping $1.
Alright. Why is it not working? Now it's like frozen.
Go to their images. Like go to Pizza
Yeah,
Hut
let's-
sizes and then go to
Okay, we're gonna have to. Okay, I'm gonna just cut this off. It's not looking good. All right, Pizza Hut. Okay, I'm not sure if this is accurate or not because this is not from Pizza Hut's website, but large pizza is let's see, I saw okay. Pizza Hut, their large pizza has a diameter of 14, and it's cut into 10 slices. Well, I need to know about the medium now. Okay, oh, here we go. medium is 12 inches and 8 slices. Oh, okay. We need to know these things. 12 inches, 8 slices for the medium, 14 inches, 10 slices for the large. All right, so we got large. Let's write down our information. Large, we got 14-inch diameter, 10 slices. And medium, we've got a 12-inch diameter, 8 slices. Okay, so that's what we need to know for our problem. Okay, I'm gonna flip over to the next slide because it's got like just workspace there. So let's kind of draw this out here. We have our large pizza, and it has a diameter of 14, and it is cut into 10 slices, which is harder to do than 8 slices. Pretend these are equal slices. Probably that's what your pizza's going to look like too. They're not going to be precise, but so what would the length of a radius of that be? What? Not 17. If our radius is 14, I'm sorry, our diameter is 14, our radius is going to be 7, right? And we are getting 3 pieces of large pizza, right? So that would be like this much right here is what we're getting. So to do the area of a sector, I need to know because I want the area of this pizza, right? So that is theta over 360 times pi r squared. So right here, I need to know what that angle would be, or I kind of need to know what that angle will be. It looks 90, but it's not. That's just my bad drawing. Okay, how many slices did we cut the pizza into? 10. So how many degrees are in a circle? 360. So 360 divided by 10 is going to give us 36, right? That's how much we would have for each slice. We have 3 slices, so if we multiply that by 3, we're going to get 108. So we're going to have 108 is going to be our angle over 360, and then we'll have pi times 7 squared. Now, notice what happened, like 108 divided by 360, oh gracious, 108 divided by 360, if I do math, enter, and reduce that fraction, it is 3/10 of the pizza. That should make sense because you got 3 out of the 10 pieces. So you really could do 3 out of 10 right here instead of doing angles for this, because you know like what fraction of the pizza that you are eating. So if we do 3 divided by 10, or 108 divided by 36, doesn't matter, they're the same, times pi 7 squared, we are going to get 46.181. So 46.181 square inches of pizza. Right, that's our large. Okay, now for our medium, we have our pizza is cut into 8 slices, And we have a diameter of 12, so what would the radius of that pizza be? 6. And we're getting 4 slices of this. So I could do the angles for this, or I could just think about the fraction of the pizza. How much of the pizza are you getting there? Half, right? Or 4 out of 8. So you could do it either way. If you want to do angles, you can do 360 divided by 8. Each central angle there is 45. You're going to multiply it by 4. That's going to give you 180. 180 over 360 is half. So we would have, you could either do it this way, 180 over 360 times pi 6 squared, or you could just do 1/2 times pi 6 squared. And when we do that, we are going to get 56.549. So 56.549 square inches of pizza there for our median. So which one would you go with if you want the most pizza? You want to go with those medium pizzas, right? You would get more pizza for that. And not just because you're getting more slices, right? So, very important. Next time you order pizzas, go into this level of depth here. I think we did order pizzas for a party one time, and I did do this. So, not the slices, but like I found the area of the pizzas to decide whether we should get the medium deal or the large deal, you know, because I think I did do this.
Do that again.
Mm-hmm.
A good idea.
Yeah.
Thomas Burton needs some money.
Yeah.
Get the school to donate. We have dollars for a reason.
You think they just awarded the grants for class? You think I could write a grant to get pizza for the class? I'm afraid that one's not going to get approved. But it would be fun.
Get the clipboards or something.
Yeah. All right. So formula for arc length. All right. So a sector is the whole slice of pizza. So if a sector is a whole slice of pizza, the arc length, the arc is just the crust. Right? It's just the length of that outside edge. So whenever you see a picture that's asking you about arc length, it's going to look like a sector. But if it's asking you for the length of an arc, it only wants the outside of that. So there are 2 different formulas you can use for arc length, depending on which formula you use for circumference, right? Because it's just a fraction of your circumference. 2 pi r or pi times diameter, those are just our formulas for circumference. For this particular problem, I would use the first one because they give you the radius of this problem. Although it's not very difficult to double that radius and use the second one if you prefer. So for arc length here, we've got a central angle of 135. So our fraction is going to be 135 out of 360. Right? And so that is the fraction of the circle that we are looking at, and we are going to do 2 pi times the radius, which is 12. And so if we do that over here in the calculator, we will have 135 divided by 360 times 2 times pi times 12. And we have 28.274. Oh, sorry. And this arc lengths are just going to be measured in units, and I didn't put any on this one. Let's say that's feet. So if that's feet, this would be feet. Because you're not talking about square area. Here you're just talking about the length around that outside.
If you did a real world Wednesday one, you can do a Christmas tree skirt.
Mm-hmm. We could.
But we already skipped real world.
We did, didn't we?
We'll do it tomorrow. No, we have.
Gotta do check-ins tomorrow.
Friday, real world Friday.
Maybe. We could maybe do this.
So it is okay.
Yeah. All right. Okay. Questions. All right. So let's look at almost the same problem. We got the same scenario. Larges, you get 3 pieces. Medium, you get 4 pieces. But this time we don't care about the amount of pizza. This time we are ordering the stuffed crust pizza. And the only thing that we care about is how much stuffed crust we get, because that is our favorite and we want to only eat the crust. Or that's all we care about is the crust. So if we only care about the crust, we're not doing area of a sector anymore. We are doing our arc length, right? Because we only want that piece on the edge. Now, technically, I mean, the crust does have some width and we could find the area of it, but let's just do arc length for this to see. So what do we need to solve this problem? It is the same information as we needed before, because we still just need radius and we need to know how many slices are in each pizza. So radius and slices per pizza. For that, which we already found, so we can use our information that we have. That next slide has some room for work there. So let's draw out what we would have. We got our large pizza. It is split into 10 pieces. It had a radius of 7. We are getting 3 pieces, but we only care about the crust here. So we're doing arc length instead of area. So it's very similar, but instead of being a fraction of the area, it's a fraction of the circumference. So we could do like we did the last problem. It was 108 out of 360, or that's just 3/10 because it's 3/10 of the pizza, right? Times, this time we don't want to do pi r squared. We want to do 2 pi times our radius, which is 7, or if we wanted to, we could do 14 pi. We could just do pi times diameter. Either one is going to give us the same amount here. So if I type this in, 3 divided by 10 times pi times 14, I get 13.194. And that's 13.194 inches of crust for our large pizza. Okay, medium. We're going to have our pizza. It is split into 8 pieces. We are going to get 4 pieces. And we only care about the crust here. So again, you could do angles if you want, but this one especially is very easy to, it's 4 out of 8 pieces. So it is 1/2 of our pizza. And our radius on that was 6. Or you can do the diameter, which is 12. So you can do 2 times pi times 6. Or if you want, you can do 1/2 times pi times 12. Both will give you the same answer. And so if we do 0.5 times pi times 12, we're going to get 18.84. Well, actually 8.5. We'll round that up. Inches of crust. So overall, our medium is our better choice in both of these options. However, I feel almost like we should not have looked up how many slices were going to be in there and just gone with 8. Because let's just look, I'm just curious. Let's say, like even drawing this, I feel like they're not going to cut it into 10 slices most of the time. It's hard to do. It's much easier to cut it into 8 because you can just cut it in half this way, and then split each one of those in half. So let's say they mess up and they only do 8 pieces, right? What if we get a large pizza where there's only 8 pieces? So let's say it looks like this, which is not what, let's say our large looks like this. And we still have a radius of 7 and we still get 3 pieces. What would change about our formula there? It'll be 3/8 instead of 3/10. So we have 3/8 times 14 pi. And let's just do this out of curiosity. 3/8 times 14 times pi is going to be 16.49. Still not bigger. You'd still be better off with mediums. I wonder, let's go back over here. I want to know about this one. Well, I don't have that written there. Let's see. If it was area, it would be 3/8 times pi times 7 squared. You'd have 57. What was our answer for the medium pizzas? 56. So if it was 8 slices, you'd actually get a little more pizza with the large pizza there. In fact, when I do this again with second period, I think I'm just going to go 8 slices so that it'll be more interesting there for that. All right, so try these two on your own right here. Find the length of the arc and the area of the sector that goes with it. Well, actually, yeah, this one, area, it tells you which sector to look for. There, so try those on your own. Let's look at what I got here. Right, so for the arc length of DC, I got 20.944 centimeters. For the area sector of DAC, I got 125.664 square centimeters. For the length of the blue arc, I got 65.973, and there's no units on that one, but it'd be just units. And then area of the white sector, I got 424.115. Okay. I did see some different answers for that last one, that 424.115. Some of you have numbers that are bigger than that. What's the trick on that one? Yep, Miles. Yes, you have to subtract 210 from 360 because it's asking for the white sector, not the blue one. So you're going to get 150 instead of using that 210 again for that. If they had asked for the blue, then you would just use the 210. Okay. Any questions on those? Okay, here. Okay. I've got just a couple more. In fact, I might skip 8. 8 is a pretty straightforward problem. I would like to look at 9 because it is a backwards problem. They give you the area of the sector. They ask for the radius of the circle. So if I were to find the area of that sector, I would have to do 80 over 360 times pi times x squared, because my radius is x. So that will equal the area of the sector, which they tell me is 4.5. There. Oh no, this looks kind of complicated. How do I solve that? You can always use Desmos. So it's not a terrible idea. This is not that hard to solve by hand, and I'll show you how in just a second. But if you see something that looks scary to you, you can use Desmos on everything. Here, so if we go to Desmos, tell me what to do, Peyton. How do I solve that?
You do 80 over 360.
Let's do a y equals.
Or yeah, y equals, and then pi x to the second, and then you'll get down the line, and then y equals 4.5.
All right, and then down here, y equals 4.5, and I'm looking for where they cross. I've got two places where they cross, but does it make sense to have a negative for this one? It is not, because we're talking about the lengths of things, so that would not be the answer that we want to use. So 2.539 is what I'm getting for my answer. Now, let's do that by hand. It's not terrible. It just looks a little scary because of what all you have. But 80 over 360 times pi, we can do in our calculator. So 80 over 360 times pi, we can do that in our calculator. So what we really have here is 0.6981 x squared equals 4.5. What would I need to do next? Divide by that 0.6981. So I'll do 4.5 divided by, I'm just going to do answer there. So that gives me 6.445. So x squared equals 6.44577, and so on. What did I do last? Square root. So I will square root that answer, 2.539, which is what Desmos also gave us. As our answer. Okay, questions? Yes. The answer, like I'm doing right there, if you do second and the negative key, it'll pull that answer up. But it's pulling the answer from the line before, so like I would not want to do square root second answer now. It would give me the wrong answer because it's taking the square root of that line. So when you're doing that, you got to make sure you're doing it in order there. But the second and the negative key will pull the answer from the line before for you. So that's nice, so you don't have to type the whole thing in. Or you can just type the whole thing in. But don't round it off till you get to the very end. Or use Desmos. Any of those is fine. Okay? All right, questions?